So the first page, the solutions are all already online actually. Okay, so I will just what do you call it? I will just do the some of the tests. I will explain why test point method works, and then I'll just do some. Then once we finish off already, we'll just start doing the substitution question. I think some of you feedback that the what do you call it? Sometimes the substitution can be difficult. I agree lah. Sometimes it can be difficult. So just practice some. But don't forget that your worksheet, the revision package, there are a lot of substitution there lah. So if you're not very familiar, just do all of it. Okay. So I think should be quite okay. So now let's talk about test point method. Now some schools okay, I'll just tell you what school So alright. If your school keep asking you to draw to solve inequality, is you don't need to draw the graphs okay. So like there are a lot of ways to solve inequality. You can sometimes draw graphs, sometimes you use I think most schools use test point method, so just use test point is easiest. And then when it comes to modulus function, today the crux of it I think is a modulus function. I would want to do the modulus function, okay, at least for the 1 hour behind. So let's look at the test point. The test point method is very simple. Essentially what you're talking about is that because right in secondary school we encounter a few graphs. Okay, one graph is at y equals to x minus a square, which is something like that. So this is a. Yeah. Then if say y equals to x, maybe I just draw minus a x minus b, where b is bigger. So I'll just draw this one. This is a and b. Okay. Then if minus a x minus b x minus c, then this will be like something like that. This is a, b, and c. Okay. Now what you realize is that whenever you cross a divide the sign changes. Do you see that? So every time you cross yes. Oh, here you go. So for repeated roots, the signs what do you call it? Repeats. Just repeat. Okay. So if you look at the first one, I'll just do the quick one. So the first one, quite straightforward. You just do the test point method. So you start off with 0, right? This is 2. And there's a 3. Okay. What do you want? You essentially want, you put like super huge value. Usually I'll say just put 1 million. So 1 million, if you put 1 million is positive, 1 million is positive, then 2 minus 1 million is negative, right? Okay. So 1 million, if you put x 1 million, super huge value. So this is positive, multiplied by negative, multiplied by positive, right? This entire thing is negative. Okay? So this is negative. So if this is negative, this region is negative. Every time you cross a linear divide, a linear root, right? You will always alternate. Just alternate. So minus plus, minus plus. That's all. So you need to understand test point. Then once you're done with that, you will get this as positive because you want it to be positive, which is here. This is positive here. So essentially you get x less than 0 or between 2 and 3. Yeah, okay, students online. One here will be, I think we 4 minus 5 minus half. Put a super huge value. Super huge value will be so this one will be when this is positive, this is positive. Every time you just alternate. Every time you cross the divide, you just alternate. So then because you want it to be negative, so it's this one, this one, this one to this one. So there you go. This case here, hence x is at both negative 5 or minus half x between 4. Now the thing is, if you want to sketch it out, it's like that lah. That's it. Okay. Then for the third one, I'll just do it quickly. Okay, so this one is 4 minus 5 minus 3. Remember, guys, this guy is what we call a repeated root. Repeated root, meaning to say, repeats. The sign repeats. It's super binary. The idea is just positive and negative. It's very binary one. So you put a very huge value. When x is 1 million, this is positive. When x is 1 million, this is positive. X is 1 million, this is positive. So everything here is positive. Easy game. Okay. Then you reach until here is negative. Now, here you repeat. If this is negative, you repeat negative. If this is positive, you repeat positive, okay? So this is called repeated root for a region. The reason is it repeats lah, just like the name suggests. This will be minus, and this is plus. Then this will be here to here, guys. Don't forget about this equal sign here. This equal sign equals to 0. This one, a lot of times students will forget this equal. So hence x at most 5, or x equals to -3, or x is at least 4. Now the question is, how come you can equal? Because the graph looks like this, guys. It looks like that. Okay, so that it can equal to 0 here. You touch here. Okay, I'll just quickly do this. Part 4.1. You have -1. 3/2 is where? 3/2 is then 5/2. Now this guy is a repeated root. Just repeat. Repeat just means repeat the sign. So you put a super huge value 1 million. 1 million. Okay. So if x is 1 million, this guy is negative, right? You don't really need to know the actual value. You just need to know the sign. That's all. So this guy is always positive. So you just positive. This is positive. So overall is positive. So you know the overall here is positive. Okay. Sorry. Overall is negative. My bad. Overall here is negative. Okay. So negative plus. This is negative. Then you repeat. This is minus. This is plus. This is minus. Every time you see a repeated, you just repeat whatever it is. Then every time here you just alternate. That's all. So once you get that already, that's fine. Then you want the positive value, so it's here to here. Don't forget, you can also equal to 0 here. Okay, the 0 is here. So this case here is negative. It looks like that. So essentially, x this guy is what? This is always positive. Meaning to say the root, you can x squared plus 2 equals to 0. You can reject the root, right? There's no real roots, right? Because it is always positive. If this is always positive, it will not affect the graph. Okay, it will not affect. You won't have a root there. So if imagine you see I'll show you there's more. So if you see you have just ask yourself, if you put in calculator, it's quite easy. So you see y equals to, let's say, x minus 1, x plus 2, x minus x minus 3 . Okay, this is the graph here. Okay, this every time you cross a root, right, you will swap the you ensure that there's a root along the x-axis. But once you swap one and make sure like this you what I do is I just copy this one. So now I make this always positive. So I remove away this one. Okay. The graph now only have one real root. Okay, this guy will never spawn a root on the x-axis. X opposed to this one. Okay. You see that? Because this guy will not have real roots, man. This is always positive. It will not affect the overall negativity or positivity. This guy is just too positive. Okay. So it doesn't care. It won't show on the root. So if always positive, you just ignore it actually. Then you just need these two roots here. So you have minus root 3 and root 3. Then you have a 1 here. This is a repeated root. Remember, this is a repeat. So you put a super huge. This one got root. This one got root. This one is x squared equals to 3. X equals to plus minus root 3. So you put a super huge value like plus. When x is super huge, this is negative. So this is negative. This is positive. This is positive. This is negative. So you want it to be positive is here to here. Always positive. Okay. Similarly with this one, you check. So this one will be okay. I think we need more time here. I thought we could skip faster, but okay. We just take some time. 0. Then we have minus root 5 and root 5. This one always positive. You can check lah. Usually they'll say show that it's always positive. You can just complete the square. You can do that. It's always positive, right? But the fact that it's always positive, you don't really care. It won't affect the number line. Okay, it won't, because you can just replace it with a positive number there. So once done, you have put x super huge. This is a repeated root. Repeat because of this guy here. This is a repeated root. This is not a repeated root. This is not a repeated root. The repeated root has to be like square outside. This is repeated root. Okay. This is not. This is just a normal plus minus root 3. Then what you do is you just put the super huge value. You realize it's negative, so it's negative plus negative. So you have this over here, this over here. Don't forget you can equal to this point here. Okay, let me just draw it up for you lah. Rational function, the only topping icing on the cake, the caveat is just draw the vertical asymptote, because the vertical asymptote now is x equals to 0 or x equals to minus 2. So you can just 0. Just list down all the roots as per usual. 5/2 is over here. Then what you need to do is just draw the vertical asymptote. I will suggest you to draw vertical asymptote. Then you know that actually the vertical asymptote, that just means you cannot let x equals to that region. You can let x equals to 1, can let x equals to 5/2, but cannot let them be these two values here because they are vertical asymptotes. Alright. Then similar, you do the same thing. Test point, put a super huge value, x is a million. A million, this is positive. A million, this is positive. This is positive, this is positive. Positive, multiply positive, divide by positive, they are positive, overall positive. Then you just alternate. Easy game. Okay. Alternate. Then once this is done, what am I supposed to do? I need the positive region, so it's here to here. Here to here equals to here to here. You see the sign is super important. You cannot equal to the vertical asymptote there. Okay. So this one, quickly do it also. 0, 1, minus 2, minus 2/3. Vertical asymptote. Vertical asymptote. Plus, minus, plus, minus, plus. Negative is here. Alright, so the one on top is always positive, no real root, so that's fine. Draw it. 0, 1, no real roots, always positive. You key in calculator, I mean, don't really need to key in, but okay. Repeat. Vertical asymptote, because they are the root from below. Positive, negative, negative. So you want it to be here. Okay, no, cannot equals to that juncture there. There you go. The next one, the top is always negative, or rather, the top doesn't have real root. Okay, what is the main the thing that I will highly encourage you to do is multiply both sides to -1. Never leave the x squared negative. That is usually the worst kind of careless mistake students will make. This x squared, they left it in negative. So I'll just change it first. I don't really care. I'll change to this case first. I swap it. Okay. So just change it to positive first, because then you realize the top is always so usually what they like you to do is complete the square lah. So you just complete the square, give them like pretend you know what's actually you know what's going on lah. It's just that they want you to know that the top doesn't have real root. So usually they want you to complete the square. So let me just this one is just 19. X squared plus 1. Okay. Yep. Now the top is always positive. The bottom is also always positive. In other words, the one that decide whether it's positive or negative is only this bugger here. This is the only root which causes the havoc. Okay. So put it here. The -2, then bring it down. This is positive, this is negative. So we just want this one. So leave it here. So then the next one, draw it out. This will be 0, 1, minus, sorry, -2, -2 third. Easy game. Huge value will be positive. Repeat, this guy is repeating. Repeats as well. So plus, minus, plus, minus. Just repeat. So once you repeat, you just you want the negative region, which is here to here, here to here. So the last one, I'll just explain a bit. The last one is this and this root you can simplify, you can cancel it out. You see that? So if I were to factorize this out, you have to be slightly careful here. This negative don't make it disappear. Cancel it out. I think a lot of you don't worry, just cancel this out. Then this will be number 2. This will be a repeated root instead. So this guy will be minus 3x minus 5. X minus 1 square, then 0, okay? Then what you do is you can multiply and negative both sides to remove the negative, not an issue. But if you want to do this straight, also can, not an issue. So 0, 1. Then 5 over 3 will be bigger than 1. Put a very big value, a million, a million, a million. Positive, positive, positive. But this negative here will render it to be overall negative. Negative. Oh, this is a repeated root. Plus, plus, minus. Then you need it to be positive, which is here to here, here to here. There you go. In the end, we finish the whole question here. Okay lah. Now, can you take note? Test point method, what is the main thing? The main thing is, when it works is you need to ascertain the roots from the top and the denominator. You need it to be factorized. The main thing is you need it to be in factorized form. So if you have questions like this, right, you make sure you cross multiply top and bottom, then you make it factorizable, then you just ascertain just use test point.